Hello everybody, this is Gary Mrozinski and welcome to the second half of Chapter 5. Chapter 5 of The Microeconomy Today by Schiller and Gebhardt and published by McGraw-Hill. In the rest of Chapter 5, we're going to talk about the concept of consumer surplus and also utility theory, which we touched on in the last video. Now, consumer surplus has to do with the fact that for any given product, each of us as consumers has some maximum price that we're willing to pay for that product. And for each of us, it's a unique price, and we might not have a very precise number, but we have an idea of what the most we would pay for any particular product might be. And this is part of the explanation for the law of demand. Remember, the law of demand says if the price of the product comes down, the quantity demanded by buyers goes up. As the price goes up, the quantity demanded by buyers goes down. So again, if it's a product for which you have a maximum price, if the price is too high, you won't buy. But if the price were to drop down to below whatever your maximum price is, you and lots of others like you, a larger pool of buyers now, are buyers of that product. If the price of the product were to go up from that point, now there's a smaller pool of buyers for whom the price is not exceeding their maximum price. Now, consumer surplus is when you compare your maximum price to what you actually pay for it. Assuming your maximum price is above what you paid for it, then there's some amount of consumer surplus. I'll give you a simple example. When I bought my last smartphone, and it was a year ago, I was replacing a phone that I had bought 3 years prior to that. I think the price I paid the first time, the previous phone, was $600, something like that. So I had this price in my head of, 3 years later, $600 plus some moderate amount of increase. But I was surprised to see how much more expensive this new generation of, it was an iPhone, iPhones had gotten. $1,000 to get sort of a, the comparable size iPhone. Of course, it's more powerful now with more storage. That was beyond my maximum price. I was not a buyer in that market. But then I discovered that they were selling a lower cost version of this iPhone, which was a smaller display and less storage, for $700. Now that was not beyond my maximum price. I ended up buying the $700 version. So think about what happened there. If the price is $1,000, there's going to be fewer buyers. If the price drops down to $700, now there's more buyers for whom their maximum price is not being exceeded by the offering price. Consumer surplus is the difference between your maximum price and what you actually pay for it. Again, assuming that your maximum price is below what you paid for it. So there were people that are willing to pay $1,000 for a new smartphone. If they're able to buy the smartphone for $700, then those buyers are experiencing $300 of consumer surplus, which is good for them. When there is consumer surplus, it's good for the consumer, it's bad for the seller. If you are the seller, you're trying to minimize the amount of consumer surplus. And so what price do you pick? It's hard to say if you're going to offer everyone the same price. Imagine if you were able to offer each buyer a different price and try to get that price closer to their maximum price. That's an idea we're going to talk about in the next few minutes. This is an example of a really high-end product. And in this hypothetical market, this is the demand curve you see graphed here. There are, 8 possible buyers, but each of them has a different maximum price. And each of their maximum prices are a point on the curve. So in this example, the price that this car is being offered for is $845,500. Fred is a buyer. His maximum price that he's willing to pay is $1 million. Michelle is willing to pay $950,000, so Michelle's a buyer. Hua is willing to pay $900,000. Carlos, $850,000. John is not willing to pay $845,500. Neither is Marty, Bob, or Blaze. So they are not buyers. If the price is $845,500, there are 4 buyers in this market. The 4 that are higher up on this demand curve. Now, consumer surplus, remember, is the difference between what your maximum price is and what you actually paid for it. So if it's selling for $845,500, Carlos has just a little bit of consumer surplus. He was willing to pay just a little bit more. Hua was willing to pay, more than that. And then Fred has the most amount of consumer surplus. And so again, consumer surplus is something that's good for the consumer, not good for the seller. The seller would want to try to minimize consumer surplus. Here is consumer surplus for each of the buyers. And again, it's the difference between, in Fred's case, $1 million, his maximum price, and $845,500, what he actually paid for it. So he's experiencing $154,500 of consumer surplus. And you can see Michelle, Hua, and Carlos have different amounts. So you can shade in that triangle in the upper portion of this graph to represent consumer surplus. The amount that buyers were able to more or less save by not having to pay exactly what their maximum price was. If you are the seller, you would like to get each of the buyers to pay closer to what their maximum price is. But how do you do that? You do that through price discrimination if you can. Price discrimination is when you charge different buyers different prices. And again, you would want to try to get each buyer to pay closer to what their maximum price is. Think of a product that you've purchased in the past where you think this is happening, where the seller is trying to learn about what your maximum price is and sell you something that's closest to that maximum price. Have you ever bought a car? Yes. Car dealers. So if you're the seller, how would you price discriminate? What are some techniques? Separate the customers and deal with them individually. Does this happen when you buy a car? When you walk into a car dealer's office, you get separated and sent to a cubicle somewhere, right? Where no one can hear what's going on in your conversation. You're not supposed to be hearing other conversations. You separate so they don't know what kinds of offers each customer is getting. Discover their maximum prices and make the deal at that price. What's the first question a car salesman or a car saleswoman asks you when you walk in? How much you want to spend? What's your maximum price? And now they know what their goal is. Their goal is to get you to spend that amount. This technique works best when consumers don't have perfect information. Well, when products are selling at all different prices, think of other products that are sold this way. How about jewelry? If you don't really know what other buyers are paying exactly for that product because it ends up being a negotiated price, then you don't have perfect information. So it works best in that kind of a market. It works best for the seller in that kind of a market. So again, this Porsche Spyder, which is sold for $845,500. If everyone bought at the same price, in other words, if there was no negotiating happening, it was just one price that everybody paid, they would sell 4 of them in this market, and their total revenue would be $3,382,000, which doesn't sound so bad, but if you could get each buyer to pay their maximum price, that total revenue would go up, wouldn't it? If even you only sold to those 4 buyers. Fred had, $154,500 in consumer surplus. I think that's what it was. Well, if you can get him to pay $1 million, think about just that one buyer, how much that makes your total revenue go up. So how do you get Fred to pay $1 million? How about if you price the car at $1.2 million and let him negotiate the price down to $1 million, down to his maximum price, and then be a little bit more flexible with the other 3 buyers who have lower maximum prices and try to negotiate down to exactly what their maximum prices are. If you're able to sell to those same 4 buyers at their maximum prices, your total revenue is $3,382,000. $3,700,000. Now that would be like perfect price discrimination. And it's not a perfect process, but that would be your goal. You want to try to end up somewhere between $3,700,000 and $3,382,000, which would have been what you would have gotten if everybody paid the same price. The more you can minimize consumer surplus as the seller, the more your total revenue increases. So again, techniques that sellers would use in these cases: divide and conquer, separate the buyers and try to negotiate with them individually. The other thing is, you are dealing with, when you buy a car, an expert negotiator. They do this every single day. You do this occasionally. How often do you buy a car? Once every 3 or 4 years, maybe, if even that. So you have limited experience as a negotiator. They have a lot of experience as a negotiator, so you have a disadvantage. There's no transparency. You don't know what the buyer in the next cubicle paid for the car that they got. It might be the exact same make and model with the same option package, but you don't know exactly what that person paid. The dealer probes to discover what your maximum price is. Again, the first question they ask you is, how much are you willing to pay? And then they try to obscure that a little bit by saying, what can you afford per month? And then you don't know exactly what you paid for it necessarily. Again, that's a negotiating technique. Now, getting back to utility theory, remember, we purchase products because we derive utility from them, benefit or satisfaction. And we're looking for value. We have limited resources, a limited amount of weekly income to spend on all of the products that we buy in different quantities. We're trying to maximize the total utility we get from our total expenditure that week. That's our goal, to maximize utility. So as we buy units of different products, what we're doing is we're comparing the marginal utility of that unit of that product to what you paid for it. So really, you're making your decision based on marginal utility per dollar, which is at the bottom of your slide. You can see MU divided by P. That's the price you paid for it. That's the same as saying marginal utility per dollar. That's what you use to make your decision as you're buying each of the products you buy during the week. And we're going to sort of step through an example of how this might happen. Now, this is an economic model where we simplify the situation for the purpose of understanding utility theory. Marginal utility per dollar, MU divided by P. Ratios must be greater than 1 to be considered. That means the marginal utility exceeds the price and the exchange will be beneficial. All right, so we're going to put together an example of a consumer spending a limited amount of resources, income, to purchase products. And these are the assumptions we're going to make. First of all, we're going to assume that the consumer is behaving strictly rationally and that there are no other types of influences on this buyer, none of these socio-psychiatric influences that we talked about early in this chapter. It's thinking strictly rational based on the data that this person understands about their preferences. They understand their preferences. This will be another assumption. And in fact, we're going to assume that the buyer can quantify their marginal utility. I spoke earlier about this fictional unit of measure called the UTIL, U-T-I-L. For economists, that represents utility. That's a measurement of utility. So marginal utility is the amount of utility you get from consuming one more unit of something. So many UTILs. It is assumed in our model that the consumer is able to quantify that. And you're actually going to be given the numbers and asked, if these numbers represent the marginal utilities for this particular buyer, what decisions will that buyer make? That's what you're going to try to do. Budget constraint, this is obvious. The buyer has a limited amount of income, and that represents their budget. And products have prices, another assumption that's pretty basic. So you're going to step through, in this simple example, the purchases. where you're making your decision on purchasing the product that has the largest marginal utility per dollar, the largest value of MU divided by P. That will be the next product you buy. And then after you've purchased that product, you're looking at the next dollar you spend, or the next $2 are going to be spent on the next product that has the most marginal utility per dollar. And when I show you an example, this will be much more clear. But that's what we're trying to do. You're going to step through the purchase process and write down each of the purchases this buyer will make, where the next purchase will be wherever there is the greater marginal utility per dollar. In our simple model, the buyer is going to be buying just 2 products, some number of units of 2 products, spending all of your money on just 2 products. The utility maximization rule says that the consumer allocates his or her income so that the last dollar spent on each product yields the same amount of extra utility. So the marginal utility per dollar is the same for the 2 products. That's when you've reached optimum consumption. That's when you've maximized the total utility received for the income you spent. So that equation on the bottom, so if it's product X and product Y, it would be the marginal utility per dollar for product X is the same as for product Y. And as we look at the example, this will again be more clear. So here's my example. Suppose Garbanzo is analyzing which combination of 2 products he should purchase with his fixed daily income of $10. So this is each day he has $10 to spend, and he's spending it only on apples and oranges. This is an economic model where we're simplifying the more complex reality. The more complex reality is that he's probably buying, I don't know, a dozen different products in a day, possibly. Well, let's make this more simple so we can understand utility theory, and then we can extend this to the more complex reality. This buyer is only buying 2 kinds of products, apples and oranges. Each of them has a price. And again, we know the marginal utilities for each unit of that product that this buyer might be purchasing. So he has $10 to spend. We're going to step through the purchase process as he spends each of those $10 on only apples and oranges. Remember the law of diminishing marginal utility. The law of diminishing marginal utility says that if you consume more and more units of the thing, the marginal utility is going down. The marginal utility of each additional unit you might consume diminishes, like the pizza example. As you eat that first piece of pizza, it has lots of marginal utility. The second piece has a lot, but not as much as the first. And the third has less than the second, and so on. It's diminishing. So again, we've assumed that this buyer knows the marginal utilities of each of the units of these products that he or she might consume, and it's represented in this table. So just look at, there's 2 products, apples and oranges. The prices are different. The first column under apples, you can see if this person consumes 1 apple, they gain 10 utils of satisfaction utility. If they consume the second apple, they have 8 utils. The third gives them 7 utils. Now go over to the oranges columns. The leftmost column under oranges says that this one buyer will derive 24 utils from the first orange he or she consumes, 20 utils of the second, 18 utils of the third orange. Okay, so now you know that. So you're getting more marginal utility per unit consumed, but the price is higher. So that's part of it too. Remember, you're making your decision based on marginal utility per dollar. So we have to add a column for marginal utility per dollar for each of these products. And you can see that is filled in for you. So the apples are $1 per apple per unit. And so the marginal utility per dollar is going to be the same as the marginal utility column in that case. Move over to the oranges columns. The marginal utility per dollar, the first unit represents 24 utils of extra satisfaction going from 0 to 1, but it's $2, so that's 12 utils per dollar. The second unit has a marginal utility of 20 utils, but it's $2 per unit, so that's 10 utils per dollar. So the utils per dollar columns are the ones we base our decisions on. The marginal utility column tells you how much utility is actually gained if those units are to be consumed. So what you need to do is, now the next page is going to give you, I wish I could show you these both at once as I explain them, but the next slide shows you the order of the purchases. But we can kind of step through this, right? Without even advancing the slide. What would be the first thing this buyer would buy? Would it be an apple? Would he buy the first apple or the first orange? Remember, you're making a decision based on marginal utility per dollar. It would be an orange, right? Because you gain 12 utils. All right, so that one is consumed. You've spent $2. Now you only have $8 remaining. All right, what are you going to buy next? Well, it's a tie, isn't it? Marginal utility per dollar. You can either buy your second orange, 10 utils per dollar, or your first apple, 10 utils per dollar. Well, we're already in the orange store. You might as well buy the orange, right? So you buy the orange. You've gained 20 utils. You had 24, you've gained another 20. So now you're up to 44 utils of utility. How much money do you have left? Well, you bought 2 oranges. Now you're down to $6. All right? You've consumed 2 oranges. You have a total utility of 44 utils. You have $6 remaining. What are you going to buy next? Well, now you're going to buy the apple at 10 utils per dollar. All right, you do that. Now you're down to $5 remaining. You gain 10 utils of satisfaction. So now you have 54. You can see how we do this? We do this until our money runs out. And then you end up with some number of apples and some number of oranges. So this table sort of steps you through the decision-making process for this buyer. And you can see that there are 4 choices made. And in the end, this buyer ends up buying 2 apples and 4 oranges before the money runs out. And then the money ends up at $0. So this buyer ends up buying 2 apples and 4 oranges. So that's with oranges at $2 a piece and apples at $1 a piece. But what if the price of oranges was to drop? Think about how that would change things. Going back to that table that showed marginal utility and marginal utility per dollar for each product, that changes that table for oranges, right? Now you have to revise the column that is marginal utility per dollar, marginal utility divided by price, because the price is different now. So we're going to do that and then have you step through and see how that changes how many of each of these 2 products you purchase. And so I'll ask you to do this. Now you have to fill in a new column for oranges, marginal utility per dollar. Except now it's the first unit of oranges, it's 24 utils divided by $1. So the marginal utility per dollar is 24 utils per dollar. For the second unit of oranges, 20 utils per dollar, and then 18 utils per dollar, and so on. All right, so this really changes things. In fact, if you step through the purchases, you still have only $10. What's going to be your first purchase? An orange, 24 utils per dollar. How about your second purchase? An orange, 20 utils per dollar. How about your third purchase? An orange is your third purchase, it's your fourth purchase, it's your fifth purchase. You're going to buy 5 oranges before you consider buying an apple. Then finally you're going to decide to buy an apple because it's 10 utils per dollar instead of 6 for your 6th orange. All right? So write down the order of these purchases and then keep a running balance of how much money you have left. Now you have $10. Both of these products are $1. So there's going to be 10 purchases, right? Because each product is costing you $1. So you're going to, the total amount of units of the things you're buying is going to be 10, but what is the breakdown between the two, right? How many apples, how many oranges? Well, the answer is you end up buying 4 apples and 6 oranges. 4 apples and 6 oranges, because the price of oranges dropped from $2 to $1. All right? So, this means we can put together a demand curve for oranges. How many would this consumer buy when the price is $2? Well, we know that already. 4, right? When the price dropped down to $1, this buyer bought 6. Those are 2 points on the demand curve. If it's a straight line, you only need 2 points to be able to graph the line, right? And so there is a very simple supply schedule, that table of values, how much the quantities this person would be demanding at $2 and at $1. You plot those points. Those are 2 points on this person's individual demand curve. And there we have derived it. And so this is also showing you that we think of the demand for a product, even an individual person's demand curve for a product, it's influenced by a lot of things. It's influenced by the price of the product, rising or falling, but then it also considers the fact that you're spending your limiting income also on other products. In this simple example, we're only thinking of 2 products, but again, you could be spending your money on 10 or 12 products in a given day. So there's lots going on. This is an economic model. We simplify the situation, we freeze other variables, we assume there's only 2 products being bought, and this helps us to understand the idea of utility theory and how it is part of the explanation for the law of demand. Now let's try to extend this economic model, these simplifying assumptions. We've really oversimplified the real situation. Now think about how you might extend that to reality. Well, you don't really have numbers in your head for marginal utility per dollar for units of products. Like, how many nights should I eat out this week if it's weekly income I'm spending? Well, if I'm eating out no nights per week, and then I start eating out 1 night per week, that's going to have lots of marginal utility. But if I'm eating out 2 nights a week, it's not quite as special as when it was 1 night. Or if I'm eating out 5 nights a week, it's really a lot less special than if I were eating out 1 night a week. So the marginal utility is going to diminish. And of course, you're comparing that to the price of the thing, considering you're also spending money on other products. It's the marginal utility per dollar that makes you decide how many nights a week to eat out. So this is chapter 5. We have one more chapter coming up that's part of the demand curve. It's consumer behavior. It's price elasticity. This is a really interesting concept. It's one of my favorite topics in this course. And I'll see you in chapter 6.